In this video, I am going to explain to you about the cross-sectional method of solving linear equation. Let us say, for example, you have two linear equations a1x, okay, plus b1y plus c1 is equal to 0, and another linear equation a2x plus b2y plus c2 is equal to 0. Now, can I, through some method or the other, find out the value of y and x directly? If I use the method of elimination, okay, what do I get? What is the value of y that I get in this equation? I can write that b1y is equal to minus c1 minus a1x, okay, by taking this and this to the other side. Or simply I just remove this b1 and I can put this as minus c1 minus a1x, okay, y is equal to minus c1 minus a1x upon b1. Or even maybe can actually write this as minus b1, okay, a1x plus c1. Now if I substitute the value of y in this particular equation, what do I get? I get a2x plus b2 into a1x plus c1 divided by b1, okay, minus b1 plus c2 is equal to 0. Resolving this equation, I get a2 b1x with a minus sign plus a1 b2x plus b2 c1, okay, divided by minus b1 is equal to minus c2. I just take this to the other side, right? Or simply a1 b2x, which is this one, okay, plus b2 c1 minus a2 b1x plus minus times minus gives you plus, and then if you move this to this side you get minus b1 c2 is equal to 0. If you solve the one with x, which are these two equations, okay, you take x as common, you get a1 b2 minus a2 b1. If you move the other two to the other side, you get b2 c1 with a minus sign plus b1 c2. Or you can just write this as x is equal to b1 c2 minus b2 c1 divided by a1 b2 minus a2 b1. If you would redo this entire exercise, okay, wherein you, instead of finding the value of y, you find the value of x, what you will get is that y is equal to c1 a2 minus c2 a1 upon a1 b2 minus a2 b1, right? So these are the direct formulas through which you can actually get the value of x and y in these two equations. Now, one of the important conditions for these formulas to be applied is that the product of a1 and b2 minus a2 and b1 should never be equal to 0, because if it is, then the value which we have ascertained here and here do not apply, right?